Alright, so here's a couple of exercises for you to practice Descartes Rule of Signs. Two equations, counting up the sign changes, f of negative x, counting up the sign changes, making a little table or whatnot. So go ahead and pause the video, give those two a try, and then come back. Pause. Okay, you're back. So I went ahead and separated these out so I could see them one at a time. So here's the first one. So I first wrote down, I'll look at the degree, it's the third degree, there must be 3 total zeros. Okay, got that information. Now on the original function, I checked to see how many sign changes there are. So it only has one, from a positive 2x to negative 11. So that's one positive real zero. That's a possibility. And I can't subtract 2 from that, because if I subtract 2 I'm at negative 1, so that's the only possibility there. Okay, so then I find f of negative x, and I get that by just changing all the signs of the odd ones. So negative x cubed, negative 2x squared, negative 11. So if I look at there, they all stay negative. There's no negative sign changes. Alright, so now putting all this together in the table, for the total, positive, negatives, and imaginaries, we're just pairing up everything we have. Not much to pair up, because there's only one possibility. So I have 3 totals, and I only had one possible positive real zero paired up with 0 negatives, and then whenever I add those up I get 1. Subtract it from the total of 3, I get 2 imaginaries. Here's an instance where the Descartes Rule of Signs is tremendously helpful. It tells us that no matter what, you have one answer, one real answer, and that sucker has to be positive, can't be negative. So whenever you're listing out all the possibilities for this, using the rational zero test, we know x would be equal to plus or minus 1 and 11 because of that constant term right there. And that's 4 possibilities. But this cuts it down to just 2 because it's saying the negative ones will not work. Absolutely will not work. Okay, the other information that's handy is after we found one, either the positive 1 or the positive 11, the other 2 absolutely have to be imaginary. Okay, so that's some helpful information. On the second one, I count up all my sign changes in the original function, every single one. There's 4 of them. So I start with 4 positives, take 2 away. 2 positives, take 2 away, 0 positives. Alright. So then I find f of negative x, change all the signs of the odd ones, and when I do, everything turns positive. So there's no sign changes on f of, or g of negative x, I should say. So when I make my table to pair these things up, not much to pair. 4 possibilities. On the positives, negatives, and imaginaries, I'm going to take the 4 positives and pair it up with 0 negatives. Add those up, subtract it from the total, and I get no imaginaries. It's a pretty good case right there, no imaginary ones. Every single one of them must be x-intercepts. Okay, and then on the second case, I pair up the 2 positives with 0 negatives, subtract that from the total, I get 2 imaginaries. And then the last possibility is 0 positives with 0 negatives, which leaves me with 4 imaginaries. That one's the worst case scenario because you wouldn't be able to find them very easily at all. The middle one would be okay because you could find 2 positive ones, and the other 2 quadratic formula for the imaginaries. And notice that right straight down the middle, oh wait a minute, we got, it's like we did tic-tac-toe. There we go. There's no negative ones. Whenever you list out your possibilities, get rid of all the negative ones, it can only be positive. So again, that's kind of some helpful information for you to go trying to find some zeros of polynomial functions. The end.